So today we'll start a topic called the B tree. Okay. So what is the meaning of a B tree? A B tree is a specialized MOS host tree. A B tree is a specialized MOA search tree. So, what is the meaning of MOA search tree? In MOA search tree, we can place at most m-1 keys in each node. And each node may have at most m children, m number of children. So, your MOA search tree follows the concept of binary search tree. Follows the concept of binary search tree. Now let me explain what is the use of your MOA search tree in the B tree. So just think about, we have a node. And in MOA search tree we can place at most m-1 keys. Suppose this is your key 1, let's say it's key 2, so let's say it's key number 3. So this is the way we can place k m-1 keys. Keys are nothing, they are the values. Now your every node contains maximum m-1 keys, m-1 number of values, and here how many children you can create from MOA search tree? You can create m number of child. So let's think about, this is your first child, this is your second child. So if you will continue, you will find that we are going to have maximum m children. So this is your children number 1, let's say children number 2. So similarly here we're going to have mth children. Now it is clear that in MOA search tree we are going to place m-1 keys. Each node may have at most m number of children, and it follows the concept of binary search tree. What is the meaning of the binary search tree? We know that the left child value will be less than your parent value. Suppose if I am going to place m as your 3, let me explain. If m equals to 3, then number of keys in each node will be how much? 3 minus 1, that is 2. So 2 keys we can place. Now here I can think that this is the node, I can place 2 keys. One I place 100, next let's say that I am placing 200, and then the number of child I can create from each node, that is your 3. So this is your first child, second child, Here I can place your third child. Now it is clearly visible that we have created 3 children. And how you are going to place the values? We are going to follow the concept of binary search tree. So in the binary search tree, the left child is less than the parent value. Here is the 100. So whatever the value you will place here, that will be less than 100. How many values you can place? Every node will contain m minus 1 keys. That means m is here 3, 2 values I can place. So that 2 values will be less than your 100 because it is present in the left side of the 100, the key 100. Now I can place here 1 is 50. Another value I can place here, let's say that 80. Now you can imagine that your 2 values present in this node which is less than 100, and this is your second node or second child, I can say that. Then what will the value? The value will be arranged as per the binary search tree. So that is the right to 100 and left to 200. So that's why right to 100 and left to your 200 key means the value will be in between 100 to 200. How many values I can place? I can place maximum 2 values in each node. So here I can place, let's say the one is 150, another I placed here 180. Now your 200's right child is this one, your child number 3. So the value will be more than 200. How many values I can place? How many keys? I can place your 2 keys. So here let's say that one is 250 and as your 300. So your every node is a contains a pointer. I can say that this is the pointer which points to your first child. Here is a pointer. I can say that this pointer points to your second child, and here is a pointer that points to your third child. So this is the way we can create a MA search tree. Then let's go for the properties of B tree. Properties of B tree. So every node, the first property I can say that the property 1, every node in B tree has at most m number of children. Property number 2, every node in the B tree except root and leaf node has at least m by 2 numbers of children. If m is 4, so every node except the root and the leaf node will have 2 number of children at least. Then property 3, the root node has at least 2 children if it is not a terminal node. If it is not a terminal node, if root node is not a leaf node, then it is going to have at least 2 children. Property number 4, all leaf nodes should be at the same level. So all leaf nodes should be at same level. So that 4 properties we need to follow in order to construct one B tree. Take an example. take one example where m is equals to, let's say, 3. M equals to 3. Now, how many values I can place? I can place your m minus 1 values, your 2 values. What are the 2 values I can place here? Let's say that one value is 10, another value, let's say that your 50. So, here is 50. So, this is a pointer, this is a pointer, and let's say that this is also a pointer. This pointer points to this node, this pointer points to this node, this pointer is also pointing to this node. Now, if you say that every node, every child is going to have maximum 3 values, it may contain less than, but minimum values, we can say that your now I can place here the values as 5, I can place here values 8. There is no issue because both the keys are less than your 10, and here this node is going to have more than 10 and less than 50. I can place the value as 20, I can place the value as 40. Similarly, your third child may contain the value as your greater than 50, less than 70, another is 80. Now you can see that the properties that I mentioned in your B tree, every node in the B tree has at most m children. Yes, here at most this parent node is having at most 3 children. And second property, B tree except the root and leaf node has at least m by 2 numbers children. Yes, I can say that root m by 3 means 1 by 2, so I can say that 1, so it is having more than 1 number children. And the root node has at least 2 children. Yes, it is having 3 children. All the leaf nodes, property 4, all the leaf nodes are present the same level. Yes, it is also satisfying. So it is a B tree with order 3. M means is having the order m, and here is m is 3, so I guess that is a B tree of order 3. Let's consider another example. So, order of the B tree is given as 3. So now I can create one node here. Okay, and it is connected to another node and is also connected to your right node. Okay, and the value here I can place less than 50, and here is more than 72. Right child value will be more than 72, less than 120, and it is connected to one more node here. This is also connected to another node. This one is also connected to one more node. This one is also connected to one more node. Let me place some values. So here, just think about greater than, the value will be less than 50. So I can place the values here 20. Okay, and here I'm going to place another value less than 30. Okay, and here this node will contain the value more than 50. So I place the value as 60, and another value I placed here 70, and this 70 is less than also 72, because right, this node is present, this child node or leaf node I can present left to your root node, and this is 120, and I can place less than 120. Let's say that I place the value as your 100, and one more value I placed here, let's say that 1, 1, 1. Triple 1 value I placed here. Okay, so triple 1 values here. Then it is the value I can place here as 150. Another value I can place here 170. There is no issue. Now the aim is 3, so we can place a maximum 2 values in the node. The leaf node contains 2 values and the internal node contains single values. And how many so children can be created from every node? Maximum, that is 3 nodes. So we have the 2 nodes, there is no issue. A minimum is I can say that 3 by 2. You take that minimum number of nodes, child nodes we can create, that is 3 by 2. Alright, so there is no issue. So here you can say that if m is equals to 3, so keys will be 3 minus 1, that is 2 keys we can place, and maximum child nodes will be 3. Minimum child nodes we can say that 3 by 2. You take the floor, sorry, you take the seal, so it is your 2. So minimum 2 number children should be created from every node. Now, and the number of values we can say that, so this is the maximum number of keys, and the minimum keys we can say that minimum number of keys needed in this tree will be how much? That is your 3 by 2, take its seal, minus 1, so that will be 1. So these things you need to keep in your mind at the time of design the bit tree. If the order is given 3, the keys will be your order minus 1, here is 2, maximum child will be your then is equal to the order of the tree, and minimum child that can be created in your bit tree, that will be 3 by 2, take its seal value, so 1.5 seal is your 2, and minimum keys is how much? Minimum keys that will be placed in the every node, that is 3 by 2, floor and minus 1, so here is 1. Now we can say that minimum key we can place the 1 value, it is satisfying, so here is 50, here is 120, minimum value is satisfying, here is more than minimum value in the leaf nodes, it is okay. And the maximum child, that will be 3, so we have here 2 children, there is no issue. A minimum child will be 2, yes, root node is having 2 children, and internal nodes also having 2 children, so it is satisfying the bit tree property, and all the leaf nodes should be in the same level. So it is a completely a bit tree which is based on the your MI short tree. Let's go for how to insert the new node into the bit tree. So the next the operation that you can perform in your bit tree, that is called your insertion. So the rules for the insertions are, the first rule I can say that rule number 1 is so search the, if you are going to insert any value, then search the node where you are going to insert. So we can say that rule number 1, the element will be inserted at leaf node, Rule number 2, search the position of leaf node where it will be inserted. Search the position of the leaf node. Rule number 3, if the leaf node is not full, once you got the leaf node, then you check that whether leaf node is full or empty. If the leaf node is not full, then insert the element. Insert the elements by keeping the order or by maintaining the order. By maintaining the order. So order should be mentioned. Here the order is means we need to arrange in increasing order. In the value should be arranged in the increasing order of the leaf node values. So rule number 4, let me write here. Rule number 4 for insertion of the value in the B tree is that if the node is full, if the leaf node is full, that means k minus n values or keys, that means it contains your k minus 1 values, k minus 1 keys present in the leaf node. Then what should you do? The first step is that insert the new value in order into the existing cage. Second, split the node at its meridian, at its midpoint, into two nodes, Rule number 3 or rule number 4, sub part 3, push the midpoint value to the parent node. If the parent is full, then split the parent node as previous step. So previous step in here, rule first, step 2. You have to follow. If the parent is full, then we have to follow the same approach of your sub part of your rule 4, that is second part of your rule 4. You have to follow the same rule to split the parent node if it is containing k minus 1 cage. So we came to know about the rules for inserting the values to your B tree. Then suppose a question is given to you, insert the 130, 80 and 10 in the tree given below. Just think about, we have a tree, B tree, and what is the order of the B tree? Let me write here. The order is given as M as 3. Of order 3. If the order 3, then we are sure that the minimum values or minimum child, I can say that how many child nodes you can create with the minimum numbers. Minimum numbers will be 3 by 2. Take the seal value, so it is 2. Minimum keys will be how much? 3 by 2. Take its seal minus 1, so I can say that 1. Maximum child nodes will be 3, the order. Maximum keys will be 3 minus 1, that is 2. So whenever you are going to insert any values to the given tree of certain order, then you need to decide those parameters. What are parameters? The minimum child nodes that you can create, minimum number of keys that can be placed, and the maximum child nodes that can be created from the given waytree, and maximum keys that we can place. Now you just think about minimum child will be your 2. Yes, every node is having minimum child except your leaf nodes, and minimum keys is 1. You can say that every node is containing more than 1 values, so there is no issue. And maximum child nodes will 3, and maximum keys we can place 2. So here you can say that leaf nodes, some leaf nodes contains 2 values also. Now the question is given, you have to insert the value 130. So first you have to search the leaf node, because the value whenever you are going to insert into the waytree, the value will be inserted in your leaf nodes. So search the appropriate leaf nodes. So which is the appropriate leaf node for inserting value 130? You start from your root node 85. So 130 is greater than your 85. We will go to the right node is your 100. So again 130 is greater than 100. We go to your right side leaf node. So you reach to the position of your leaf node, and the leaf node, how many values it contains? It contains 1 value, that is your 150. So how many values we can place? We can place maximum 2 values, so we can accommodate your 130. So now I can place 130 in your leaf node. This is the leaf node. I can place your 130 here. So 130 is inserted. So there is no issue to insert the 130 in your leaf node, because it contains less than your maximum number of keys. So no issue. Now next is insert the value that is 180. So we are going to insert the next value, that is equal to 80, into the same waytree. So search the leaf node. So 80 is less than your 85. So go to the left side. Left side value is 50. So again 80 is greater than 50. So we go to the right of your node which contains 50. So right leaf node which is occupied with full keys, or I can say that this leaf node is completely full. So we cannot insert your 80 into this leaf node. So in that case, what should we do? We have to follow the rule. What is the rule? The rule number 4. If the leaf node is full, then insert the new value in order of the existing keys. So then we have to split the node at the midpoint and push the midpoint value to the parent node. So now I can say that 60, then this is the leaf node where it will be inserted, but it is full, then 60, then 70, then I can say that next element I will insert, that is 80. So keep in the order, then split. If you are going to split, the midpoint is 70. 70 will be transferred to the parent as per your rule number 4, sub rule 3. So rule number 4, part 3 says that divide at the mid and transfer the mid value to the parent. So we are going to split the node. So this node will be splitted. This node is going to be split into 2 parts. Let me redraw that one. Now, so this is your 85, the root node. Then this one is your left node of your 85. This one is your right node of your 85. It contains 100. Now just think about your 70 will be transferred to the parent. So now, who is the parent? Parent is the your node which contains 50. So now I will place 50, then I will place your 70. So there is no issue because this parent node can contain maximum 2 keys. So it contains only one key, so we can place the 70 here. Once you place it, then 50's left part is which one? Your 20 and 40. You can say 20, another is your 40. And this will connect to one node, this will connect to another node. So once you transfer 7 to the parent, then left will be 60, left node will contain 60. So this 60 will be placed here, it will be divided into two nodes, one will contain 60, another left node will contain 80. Now 60 is placed here and 80 is placed here. Now you can see that your 70 and here is 80. So 80 is the right child of 70 and 60 is placed at the your between your value 50 and your 70. So there is no issue. So you divided this node into your two nodes and the middle value is transferred to your the parent value. It is now clear to you, and the remaining structure will be as it is. So we can place here, it was previously your 90, we kept it, then your right to 100 was 130 and your 150 we kept as it is. So this is the way we have inserted 80. This is the way we have inserted 80 into your given B tree. The next is insert the 10 in the same tree. If it is 10, then you just look at, so what should you do? So 10 is less than 85, you go to the left side. So here is 50. So 10 is less than 50, you go to this node. So now you just think about here what is happening. This node contains already your two number of keys. So you cannot insert 10 here. So again you have to split it. So first arrange the elements in order 10, 20, 40. So 20 will be transferred to mid value is 20 transferred to the parent. So parent node contains the maximum keys. So what will happen? Again we will divide this 20. So again we can say that here, let me write. So arrange 20, 50 and 70. So when 20 is transferred to your parent node does not have the capacity to store the 20. So again the parent node will be splitted. So because as per your rule number 4, last sub rule that is push the midpoint values, and if your parent node is full, then previous step number 2 will be followed in the similar manner. So what should I do if the parent node is full, which cannot contain your splitted value that is transferred from the child node? So the child node transfer the value 20 to the parent, so 20, and the parent value is 50, 70. So it is already full, so we have to split it. If you are going to split, so what will happen? So 50 will transfer to the parent of your 50 and 70. So what will happen? So 50 will be transferred to the root node, and root node is not completely full. It contains only one keys, and how many keys you can place? 2 keys you can place. So that's why your 50 will transfer to here, and the 50's left part will be 20. So now we can rewrite that, redraw this B tree. Now 50 is transferred to the parent node, and the previously 85 was there, so no issue. Now just look at this value. If 50 is transferred, the left value will be 20, right value will be 70. So you kept your 20 here, you kept 20 here, and the right is your 70, right is 70. So this node is splitted in two parts. One part contains 10, another part contains your 40. Now we can place the value 10 as the left of this value, 10, and the 40 as the right of your 20. Okay, and this is your value called the 70. Okay, and the value we can place, just look at here, 70 is left part is 60 and right part is 80. So we can place here 60 here, and another value is 80 here. Okay, next 85's right part is 100, 100's left part 90, and 130, 150. We are going to keep it as it is. So this is pointing to 100, and 100 left part is your 90 as it is, and 100's right part that is present in my previous B-tree value, that is 130 and 150. Now we have inserted 10 because the last value that's given to us, insert the 10 into your B-tree. So now we have inserted the 10 in the B-tree in the leaf node. All the leaf nodes are in the same level and it is satisfying all the properties of B-tree. Now after inserting the values asked in the question 130, 80 and 10. So now you can say that 130 is inserted here, and the next value is 80, 80 was inserted here, and 10 was inserted here. Now after inserting three values, your B-tree looks like this way. This is the way you can insert any value to the B-tree by following the rule of your insertion in your B-tree. Thank you all.